These next two examples look a little bit different because we have the variable in the exponent. So for this one, we have the base e, which means we need to natural log both sides, but do a little bit extra work. So for this one, again, we want to get rid of this e, and to chunga chunga that, or the inverse of it, is to natural log both sides. So we end up with the natural log of 2 equals these chunga chunga 10 times r, okay? Now, just because this looks like garbage doesn't mean we treat it any differently. We're just going to simply divide both sides by 10. Chunga chunga. So r equals whatever the natural log of 2 divided by 10 is. So if we type that into our calculator, natural log of 2 divided by 10 is 0.07. And we'll do the same thing over here. So we have one extra step on this guy, unfortunately. We need to divide by 500. Divide by 500. So these chunga chunga, and we're left with e to the negative 0.04t equals, this is 1/2. You can leave it as 1/2, or in class, students preferred I write 0.5. Now we feel a little bit stuck. This is where I sometimes panic, but then we have to remember, if you natural log both sides, these chunga chunga. So we have the natural log of 0.5 equals negative 0.04t. And again, just because it looks bad doesn't mean we treat it any differently. We're going to divide by negative 0.04. So these chunga chunga, and we're left with t equals whatever the natural log of 0.5 divided by negative 0.4 is. Natural log of 0.5 divided by negative 0.04, 17.33. In class, students kind of questioned whether that was accurate because it seemed really big to them. So what we did is we took that 17.33 and we put it right here in for t and calculated to see if it worked, and in fact it does. Okay, so these ones want us to solve for x2, but this is kind of the opposite direction. Now we have the natural log of x equals 5. Now this is what I was mentioning. If there's nothing here, you can assume that there is an e, a base e. So we could rewrite this, e to the power of 5 equals x. We just kind of rearrange. Or if we base e these things, then if we base e both sides, they chunga chunga. So in the calculator, if we do e to the power of 5, remember we need the e, the blue, 148.41. All right, same deal here. We're going to slap an e right there, but we have one extra step. We need to divide both sides by 12. Chunga chunga, we get natural log base e of x equals 0.5. So e to the 0.5 equals x. Second natural log to get our e to the 0.5, whoopsie, is 1.65. Okay, so now we're going to use the PERT formula. We are not going to do the last example on the paper, the big long word problem. We're just going to do number 3. So what I'd like you to start by doing is writing out A equals P E to the RT. Capitalization matters here. This is called the PERT formula. There are a couple pieces here. A and P are pretty significant numbers. P is the principal. Not the principal of a school, but the principal, like the initial amount. A is the new amount. R is the rate or percent as a decimal. We always put our percents into decimals if you haven't noticed. And then T, you might have guessed, is time. That's time in years, unless otherwise stated. So the PERT formula is really important because this E calculates interest rates that are compounded continuously. So continuous interest is when you use the PERT formula. A lot of times this talks about money. So what we're going to do is we're going to solve a couple problems here in these examples, but we want to identify what pieces are what first. So it says, Joe's grandparents give him $10,000 to use for college. That seems important. Suppose his parents decide to put the money in a bank offering 6% annual interest, so that's yearly. Time is in years then. Compounded continuously. That means E. So our A value, our P, our R, and T. The question is, use the PERT formula to determine how long. That means the time is what we won't know. We don't know time. How long should it stay if they want to double it? So double the money. Well, P, the principal, is 10,000. Double that is 20,000. That's from this doubled. The rate is 6%, but the rate as a decimal is 0.06, and T is the unknown. So we can set this up. 20,000 equals 10,000. E to the R is 0.06 T. The only unknown now is T. So we'll start by dividing by 10,000. We get 2 equals E to the 0.06 T. If we natural log both sides, come up here, then we get natural log of 2 equals 0.06 T. And divide by 0.06. T equals the natural log of 2 divided by 0.06. $11.55. So it would take about 11.5 years. And again, T is in years because it said annual interest. So I'm going to pause this and let you try the next one. I'll put up the answers on the next video. I want you to try part B.